Welcome to Physics Solution Center. Today, we want to look at base units and dimensions. This is a very important topic for JAMB and YX students. Base or fundamental quantities are standard units in which other quantities are expressed. They form the base unit of other quantities. We have here the list of all the SI base units and the dimension. The first fundamental quantity is length, and the unit is meter. The symbol is m. The dimensional analysis for length is L. The mass, which is a base quantity, the unit is kilogram. The symbol is kg, but the dimension is m. Time, the unit is second. The symbol is s. The dimension is t. Electric current, the unit is ampere. The symbol is A. The dimensional unit is I. Absolute temperature, Kelvin. The symbol is K and the dimension is theta. Amount of substance is mole. The symbol is MOL and the dimension is N. Luminous intensity is candela. The symbol is CDL and the dimension is J. In JAMB, mostly we use length, we use mass, we use time. We will look at some past questions and how to answer it. Let's begin with question number 1. The dimensional symbol of tension in a string is expressed as dash. Tension is an example of force, and unit for force is mass times acceleration. So the symbol for mass is kilogram. The symbol for acceleration is meter per second squared. The dimension for mass is m. The dimension for length is L. And the dimension for time is t. We have mLt minus 2. And the answer is t. Question number 2. The dimension of power is dash. Power is simply work done over time. That is force times distance divided by time. The unit for force is kilogram meter per second squared times meter divided by second. This will give us kilogram meter squared per second cube. So the dimension will be m, L raised to the power of 2, t raised to the power of minus 3, and the answer is A. Question number 3. The dimension of Young's modulus E is given by dash. Young's modulus is stress over strain, and stress is force over area. Strain is extension of our original length. So strain has no unit. So unit for Young's modulus is taken from force over area. So force over area will be kilogram meter per second squared divided by meter squared. This will give us kilogram per meter per second squared. Why it is per meter is that 1 meter is up, will cancel 1. So when the 1 down goes up, it becomes minus 1. The dimension will give us mass L minus 1 and T minus 2. ml minus 1t minus 2. What is the question number 4? Which of the following is the dimension of pressure? Pressure is force over area. So it is the same as Young's modulus, kilogram meter per second squared divided by meter squared. Question number 5. The dimension of universal gravitational constant is dash. Universal gravitational constant, we can take it from this formula F equal to G mm over r squared. You make G the subject of formula, have F r squared over mm. F is force, r is distance. So force is kilogram meter per second squared, distance is meter squared, divided by mass, kilogram times kilogram. 1 kilogram will cancel 1 kilogram. We combine it, the kilogram comes up to become minus 1, m comes together to become 3, and s comes together to become this. We have m minus 1, L 3, T minus 2. That is A. Number 6. At what respective value of AB and C would the units of work, the joule, be dimensionally similar to M raised power of A, L raised power of B, and T raised power of C? For us to answer this question, we will find the dimension for work. After that, we do the comparison. What is work? Work is force times distance. Force is kilogram meter per second squared times meter. That gives us kilogram meter squared per second squared. The dimension will be m L 2 T minus 2. We compare it with m A L B T C. So m is representing A, which is 1. B is representing L, which is 2. And C there, minus 2. The answer is B. Number 7. The internationally agreed system of units for physical measurements are dash. This is the introduction of what we did. That is kilogram, meter, and second. That is the standard. Anything outside that is not internationally agreed. Number 8. Which of the units of the following physical quantities are derived? Anything outside the 7 that I showed you is derived. So out of the 7 I showed you, only this one is here. That means the 3 there are derived. That is 1, 2, and 3 only. Number 9. What is the SI unit of relative density? Whenever you see the word relative, it means that we compare the same thing. So anything relative density has no units. Relative density has no units. The last question for today. Which of these is a derived unit? Anything outside what I showed you is a derived unit. This was there, this was there, this was not there, this was there. The answer is C. Good. We come to the end. As an assignment, I want you to try this dimension. When you are done, to send it to the comment section. Question number 1. Find the dimension of specific heat capacity. Now, let me give you formula. Quantity of heat is mc theta. So specific heat capacity is Q over m theta. So use this to find and drop your answer in the comment section. See you in our next video. Don't forget, share, subscribe, Like it. See you in our next video.